Thank you.
Hello, everyone, and thank you for joining us for this session with Cloud Native New York. And we have with us Giri, and I think it's better that if you pronounce that name, the surname, I'm afraid I'm gonna mess it up. That is gonna talk about how to secure your Kubernetes stack, talking us through policy-based practices. And so, can you introduce yourself, Giri, and then around to Cora?
Sure, yeah, thanks. My name is Giri Radhakrishnan, and I'm a technical product marketing manager at Tigera. And I'm here to talk about containers and Kubernetes security policies.
Awesome. Okay, so yeah, so
Thank
let's
you.
get started. So as Gary said, I don't know if everybody heard this before, but he's welcome to take questions as he's talking. So feel free to unmute and ask your questions, or you can put them in the chat, and Gabby and I will speak up for you. Otherwise, yeah, Gary, the stage is all yours. Feel free to share your screen. Oh, I have to share
Okay.
my screen. Oh, sorry. That's what you meant, Gabby. Got it.
All right. One second. Okay. I hope you can see the slide.
Looks great.
Perfect.
Yeah. Okay. All right. Again, thank you. Welcome to this topic today. I'm going to talk about containers and Kubernetes security policy design. This will be the agenda. I've divided the presentation into 7 sections. Don't be scared looking at the number of topics here. It'll be short and basic. I'll start with a brief overview of Project Calico and what it is that we do at Tigera to help with cloud native journey. We'll start with application modernization and its relevance in the context of containers. Then we'll look at the topic of container security and highlight some key best practices to secure your applications, containerized applications. Next, we'll look at network segmentation, which is a very critical part of securing your Kubernetes cluster. And to better understand the best practices part of the demo, I'm going to talk about policy enforcement and policy resources in Kubernetes. Then we look at monitoring and why it's necessary to have it and how it can help detect and respond to security threats in real time. I'll wrap up with the demo. Hopefully the demo will go smoothly. I was talking to Cora and Gabby, and I was telling them I don't do this on an everyday basis, so bear with me if I'm slow with the demo or if things don't work and I'm trying to troubleshoot in real time. If you're new to Kubernetes or container networking, don't worry. The end of the presentation, there'll be a link for all the resources that you need. And by the way, everything with this demo and most of the slides here were put together by one of my colleagues, and he's actually a developer advocate, and there is a GitHub link, which is not mine, and it's actually his GitHub repo. So any questions that you have during the presentation, I would definitely be willing to answer. But if you have any questions with the demo itself, like things are not working, you can definitely contact Reza, who actually owns that GitHub repo. And yeah, you could do this, recreate the demo in your own environment. All you need is a powerful Mac or a PC, or if you have access to cloud services, you can do that. And this way, you can redo the demo part as many times as you want. So let's start with Calico. What is Project Calico, and what do we do here? It's a pure layer 3 approach to virtual networking and security for highly scalable data centers. Uh, with Project Calico, we offer free and open source networking and network security solution for containers, VMs, and native host-based workloads.
Yuri, I'm sorry, just clarify. Did
Yeah.
you say you said layer 3?
Mhm.
Are you going to go into what that means, or because if not, I would ask you to define it.
Sure. Okay. So layer 3 is there's something called a little bit of history about the layers, right? So with networking, there is something called the OSI model, which is open source interconnect. OSI stands for open source interconnect, and they came up with when the whole thing about networking, computer networking started. They wanted to standardize things, so uh, they divided the entire stack into 7 layers, all the way from layer 1 to 7, which is layer 1 deals with the lowest level of networking, where we talk about just even networking cables like the Ethernet cables, all the protocols and standards related to the network interface card, NIC cards that you use in even laptops and so on. And all these layers have different protocols. So I'm sure you would have heard of IP, which is the most uh, widely used protocol that you hear about. So all that is part of different layers within the OSI module. Layer 2 is all about switching and bridging. Layer 3 is routing, and that's why I've mentioned Project Calico offers a layer 3 approach. So we basically do BGP or any type of routing for containers. And the thing about containers is when you're building containerized applications, all these uh, containers within the application, they need to talk to each other. They need to communicate to each other using some protocol, and that is not offered by default. So you have to either build your own or use something like Project Calico. And Calico is actually, these things are known as CNIs in the container world, or CNI stands for Container Network Interface. And these are also called as plugins, network plugins. So yeah, that's layer 3. And if you're interested, you could read more about that. It gets interesting as you go to layer 4, 5, and so on. And layer 7 is, if you're familiar with HTTP, that is layer 7, which is the application layer.
So everything that is a container network interface or a plugin for Kubernetes that enables communication between containers is always layer 3. That's what you're saying.
It is layer 3. Yeah. No, not just containers. I think any communication. Yeah, that's where you have to route packets happens at layer 3.
Okay. Cool.
And also, there is of course TCP, which is at layer 4 technically, but yeah.
Cool. Thank you.
Sure. So we offer Calico, which is a free and open source networking and security solution. And Calico also supports multiple architectures and platforms. So we can install it on an x86 or ARM64. And you can install it on any environment. Doesn't matter if you're running it on, let's say an on-prem solution like Rancher or OpenShift, or if you're running it on AKS or EKS, which are public cloud platforms on Azure or AWS. Yeah, and also it's also application agnostic. So it doesn't matter what your higher level application stack is. You can run Project Calico with any kind of application. And we also talk about pluggable data plane, and I'm not sure if I should explain data plane, but it's basically the underlying, let's say, communication channel for traffic. So we offer 4 pluggable data plane modules, and when I say pluggable, what it means is we've designed the CNI in a way that you don't have to configure your data plane differently for supporting Calico. It doesn't matter what type of data plane you have, Calico will just work instantly. And you can switch it depending on your needs and environment. So
Maybe.
one is the
I'm wondering, just to explain the concept of data plane, maybe you could put it in the concept of like the other planes.
Yeah, so data plane and control plane are the two major categories. So when you talk about control plane, it's actually, so let's say you're sending out an email from your email address to someone else's email address. So what the content of the email comes under, you can assume that is the data plane. Uh, so let's say a stream of packets is going from, so technically when you send an email, the stream of packets, bits and bytes is going from your email address to someone's email. Think of the content in the email as the data plane, and all the, whatever, let's say you're sending through Google, whatever communication controls that Google is using to, understand where the destination email address is, that is the control plane. So I would say, I mean, to make it even more simpler, you're sending an actual mail from your house to someone else's house. The mail itself is the data plane, and the route that the postal service uses that will be the control plane.
Cool, thank you.
All right. So yeah, so the different data planes that we offer, we support our standard, which is based on IP tables, which is the most common and widely used data plane. It provides fast networking, security, and compatibility to all environments. The next hot data plane currently that people have started using is the eBPF data plane. eBPF stands for Extended Berkeley Packet Filter. And it's another data plane that was Calico eBPF is a data plane created by Tigera. eBPF, of course, is open source, and what we do is we use the power of eBPF to provide really fast networking and security. And if you want some more information about eBPF, it's actually really powerful in the sense that it offers developers the ability to go into the kernel level and create sandbox environments to do a lot of networking, advanced networking functions, advanced security functions, or observability functions. So they can really play around with the sandbox environments using eBPF. And this is not possible. So there's no access to the kernel without eBPF. With standard IP tables, your advanced functions is very limited, but eBPF offers you that advantage. So think of it as small kernel level software programs. So with eBPF, what you can do is this data plane will offer capabilities such as complete kube proxy replacement, source IP preservation, and DSR. These could be kind of, as I mentioned, could be slightly advanced topics. Like DSR is direct server return, and IP preservation is, so in the world of containers and Kubernetes, the source IP is always changing because that's how Kubernetes is designed. Every time traffic leaves your pod or a container, it's actually NATed, meaning you change the NAT is network address translation, and you actually change the source IP. And to preserve the source IP and make the traffic that is coming back to your pod as a standard static IP, it's actually difficult, without something like the eBPF, Calico eBPF. So those are advanced topics. I would steer away from that right now. But the thing is, there is support for eBPF. If you're using eBPF, you could use Calico. Or if you're running a hybrid environment, you can use Calico for Windows, which is, I think, it's based on Microsoft HNS or host networking system. And this can also deliver networking and security for your Windows nodes. The last one is VPP, which is the newest data plane for Calico. It's currently in the beta phase. We're testing it, but it's also another option which can accelerate your networking experience by utilizing the power of user space programming. The eBPF is kernel space, the VPP data plane is user space. And in fact, eBPF and the Windows host network system are some of the foundational technologies that provide networking, security, or even observability, and some of the container security parts like major assurance and runtime threat defense that our enterprise solutions have.
Quick question. Do you have
Sure.
any like a brief characterization of performance differences between, say, standard and eBPF and in AWS environments or on-prem?
So I don't have it currently in this slide or in this presentation, but we do have some of the presentations that focus specifically on eBPF. I would suggest definitely going on Google and finding you could just do a Google search for Calico eBPF performance, and you might have, or I can actually share it. Once the presentation is over, I can share links. There are some third-party tests, performance tests, or benchmark tests that have been done, where it shows difference between different CNIs. So not just Calico. People have used Cilium, Flannel, Calico, and multiple other CNIs to see which one performs better. And obviously, since I'm talking about Calico here, I'm not going to be partial towards Calico, but the truth is we did perform really well using eBPF data plane. There's also a performance benchmark test for encryption when you're encrypting traffic using Calico or using other encryption technologies. And there are papers published. I don't know how recent these papers are, but should be at least 1 or 2 years old. But yeah. Would you be interested? I mean, does that answer your question?
Absolutely. Yeah.
Okay.
Yeah. Thank you.
Okay. Yeah. All right. So if you're interested in knowing more about Project Calico, you could join the community. It's an inclusive, active community about cloud networking and security. So you could ask any questions about containers, Kubernetes, or whatnot. Feel free to join. We have a Slack handle here. We have GitHub, and can follow us on Twitter too. And you can drive the conversation where you see a need for change, or if you want to seek help for your Calico adventure. There are developers who are actively working on the project, and you can get your questions answered there. It's a very active community with about 9,000 members so far, and we have about 500 active contributors, which is really something substantial considering similar open source projects. All right, so we'll talk about application modernization. What I mean by application modernization is it is the process of updating or transforming existing legacy applications to make them more efficient and scalable, and also cloud native. We see a lot of organizations and teams talking about cloud native, but what exactly is cloud native? I mean, you could still just use an EC2 instance and say it's cloud native, but it's not. But let's see. I mean, this approach, the approach of application modernization, helps businesses to meet demands of some modern customers and still remain competitive. What it involves is replacing older systems with new ones, integration of new applications, and the development of new processes and workflows. And some of these approaches could include refactoring, replatforming, which is, maybe you can include Kubernetes there, or even rebuilding the entire application. And the motivation behind doing this is the problems with legacy applications. Some of them are complex, outdated, and also difficult to maintain. They may have been built on older technology platforms that are no longer supported, or require manual processes that consume significant resources. We had someone who joined and wanted to get on the DevOps path, and the DevOps and manual processes don't go together at all. What they're trying to achieve is automating the entire CI/CD pipeline, and you probably will not be able to do this with legacy applications. And what happens as a result is you may have limited scalability and you'll have poor performance and also security risks. I mean, you cannot modernize one part of your organization and leave the rest of the traditional security solutions line, uh, thinking that it might still protect your modern cloud native applications. And to remain competitive, business need to embrace modernization. So you could accelerate innovation, you can optimize cost, and also improve security. So the ideal design for cloud is to break up everything into microservices. So the whole concept about moving from a monolith application to microservices is that uh, these microservices that can communicate with each other. As I mentioned, CNI is the underlying plugin that offers communication, but these smaller services definitely need to communicate with each other. And you could also have storage could be your choice. And what this distribution allows is for you to go beyond what was possible with old technologies in terms of the problems that I mentioned: serviceability, scalability, reliability, and security. Um, and also, while application modernization can offer these benefits, going on this journey is not an easy task. It requires significant investment in people. Uh, you know, People have to upgrade their skills in terms of technologies, processes, to achieve the desired outcomes. And the right foundation must be established from the beginning to avoid high cost of the architecture. And we've noticed that it takes a lot of effort to migrate. The primary pain point is not just deciding what type of technology to adopt, but it's actually the migration process itself. And this could be a major roadblock to achieve success. Let's talk about container security next. One of the key benefits of containerization or using containers is the ability to package applications and also their dependencies into smaller, portable, and lightweight container images. So these can be shared or distributed within developers and within the development team. And by packaging your application and its dependencies within a container image, you can ensure that your application is isolated from the host system. So this is the basic premise of the difference between containers and VMs. And although you share a common kernel, this can help you to reduce the risk of security breaches. When creating container images, though, you have to be careful. It is important to include only the necessary components. And this means removing unnecessary files, libraries, extensions, dependencies that are not required. We'll get to this. I'll show you a quick demo of this at the end of the presentation, what it means to not have unnecessary dependencies and files. And finally, when you also package your application, scan them for vulnerabilities, even though you might be using minimal extensions and dependencies. The base image itself, the parent image that you use, could have some kind of vulnerability within them. So you need some kind of a scanner to scan these vulnerabilities. And there are several tools available that can help you with scanning. They can scan your container images and identify these vulnerabilities. Basically, what it'll do is identify CVEs and point out the exact CVE that is part of this part of image. And I'll also show you how to use the Tigera scanner. So we have something called the Tigera scanner, which is closed source, but you could download it. You can go to our docs page and download the scanner. You can do it anywhere. You can do it on your laptop or any Linux machine. And talking about container images, you have something called image registry. If you're not familiar with what the registry is, there are two types of registries. One is public, one is private. And the choice between using public or private depends on your organization's specific needs and requirements. Of course, some some of the bigger cloud providers, they do offer registries of their own, like Amazon offers ECR, Azure offers, I forgot, I can't recollect what it's called, but Google also has GCR. So these are container registries that these public cloud providers offer. And it can be convenient for teams for smaller projects or open source software. And private image registries may be necessary for larger enterprises that have very strict rules with respect to security or regulatory requirements. For example, government agencies and banks, they'll prefer private image repositories. It could be for several reasons, including security, compliance, and also data protection. And since government agencies and banks deal with sensitive information, that must be kept confidential. Even the access to private registries can be locked down with, let's say, your RBAC solution. What it also helps is with keeping the software assets and IP, intellectual property, within their own secure infrastructure. So this will reduce the risk of leaks or unauthorized use. So yeah. Another point I want to note here is, although it's not mentioned, also the IDEs that you use for Kubernetes, for example. I've noticed or I've heard of stories where not having a secure IDE can also be harmful, in the sense that there are attackers out there looking for ways to infiltrate, and that one of them could be through the IDE itself. All right, take a pause here if you have any questions with the previous topics, images, image registries. Okay, if you don't have questions, we'll move on to network segmentation.
I guess, Giri, maybe just to restate and trace the thread. Because so you've mentioned 3 points so far, right? One of them was just sort of this transition from monoliths to microservices, where applications are being containerized and deployed as separate components that need to communicate with each other. And then you're about, as you're doing that, of course, you have to containerize your applications so that you can deploy them to something like Kubernetes as separate components. And as you create those container images and have to transport them and store them, you have to do that in registries. And so considerations around the security characteristics of the registries that you're using. That's the general thread, right, of where you're going.
Yeah.
Cool.
All right. So we'll move on to network segmentation. So once your container is created and it's stored in your registry, what you need to do is provide isolation on the network level. So because everything is communicating on the network, you need to provide some kind of isolation. And the Kubernetes network segmentation, it's the process of dividing this whole cluster. I mean, Kubernetes cluster is actually, imagine multiple applications can actually reside in one cluster, but that's basically everything all comprising, the nodes, the pods, containers, everything is within a cluster. So the process of dividing this cluster network into smaller isolated segments is actually, network segmentation. And you can achieve this by using network policies to restrict communication between different pods or different services, or even namespaces within the cluster. So this segmentation is important for security purposes, as it helps to limit the potential impact of a security breach. So assume that your organization or your application is already breached. When you have a good network segmentation in place, what it does is it prevents the attacker from moving laterally. So if for some reason they've been unlucky with accessing some sensitive data, what they typically do is, even though they have a foothold within your environment, they'll try to move laterally to access other systems or any database or whatever it could be. So if you have a good segmentation plan in place, this will prevent the attacker from doing that. And if you're also using a good CNI like Calico, you can also add RBAC roles to your segmentation process. So this could be really helpful when you're dealing with multiple teams, developer team, platform teams, and service teams. This could be a good use case to add RBAC. So let's look at some of the best practices. We looked at segmentation. We look at some best practices for securing your Kubernetes environment. So Kubernetes has, by default, they have a built-in resource, which is called Kubernetes network policy, that can shape the security posture of your cloud-native environment. However, like networking, Kubernetes does not enforce these policies on its own. You have to delegate this function to a CNI plugin, and that's also another reason why CNI is a must-have, and it's vital to use a CNI that offers such capability to secure your environment. And these policy resources can be attached to, to namespaces and pods, and you can do this to either block or permit traffic to your workloads, your actual workloads when they're part of the application. And these policy resources, they are a great tool to secure your cluster, but they might have some limitations that might become a problem down the road unless you use advanced policy engines. These policy resources don't have an explicit action attribute, which can cause a bit of a problem in bigger cluster. You can't write node-specific policies. You don't have policies that can affect the cluster as a whole, which means you don't have a global policy framework. And of course, you could achieve some of these, or actually all three of these with Calico, and also a lot more. And similar to, so talking about Calico security policies, we looked at Kubernetes policies. Similar to Kubernetes policy, we have Calico security policies. And similar to Kubernetes, your CNI of choice might offer security resources. And for example, Calico is one. It offers two set of security resources. I mentioned global network policy in the previous slide. It can either be used alone or with your Kubernetes policy resource to further lock down your cluster and bring security to your environment. One policy is the Calico network policy, and the second is the global network policy, which can be applied to the entire cluster. So Calico network policy is like this, which is a security resource that can be applied to namespaces. And global network policy is something that you can apply to the cluster. On top of that, Calico also provides a host endpoint policy resource that can be used to secure non-namespace resources. So you can apply this to non-Kubernetes resources like host processes or even the host network cards, which is the E0 and E1 shown here.
So it's very similar to like the ingress situation, right? Where Kubernetes includes an ingress resource.
Yes.
Ingress controller, and then here so the KNP, the Kubernetes network policy, is you have a resource that is standard but not functional within Kubernetes. So you can either add a CNI plugin that works with the Kubernetes resource definition, or with depending on your CNI of choice, like for example, Calico, you can use Calico with the Kubernetes default resource definition, or just replace it and use the Calico native global or cluster scoped or namespace scoped network policies. Yeah.
And it's very, it's very rare that you'll find someone using just Kubernetes policies because they offer bare minimum. But and the other thing, when you spoke about ingress, I think the one aspect that people don't realize is by default, Kubernetes doesn't offer any egress support at all. So ingress is one thing. There are multiple tools that can do ingress for Kubernetes, like the Nginx controller and so on. But for egress, by default, you can just send out any traffic, and this is a huge security. I wouldn't say flaw, but something that has to be looked at. And it's not. It's rare that someone within your organization or within the company will, communicate out to a malicious source. But it could always happen. You never know. Or any kind of command and control communication can also happen if you don't have a proper egress control.
The Kubernetes network policy, the default Kubernetes network policy doesn't cover egress.
I think it's yeah, you can't do much. It has very basic functionalities with the default policies.
Interesting. Cool. Okay.
All right. So let's look at monitoring. It's very critical. I mean, spoke about my previous company where we were doing monitoring, and it could actually help you with a lot of security use cases. So there's this belief that you cannot secure something if you cannot see something, or a similar phrase that a lot of companies use, and that's why monitoring is critical. And it's a very critical component for container security because it'll allow administrators to detect and respond to security threats in real time. And also the fact that with containers, the applications, they are highly dynamic and distributed. So if you've ever worked in a Kubernetes environment, you'll see that pods can sometimes restart and for some reason. I mean, usually it's some kind of problem within the pod itself. And these restarts can sometimes happen even within a few minutes or even a few seconds. And when I mentioned about the source IP being changed and the natting and all that, so there's so many things going on just with a single restart, and you have hundreds and thousands of containers within your application. And it's also distributed. You can have some workloads running in your on-prem Kubernetes distribution. You could have some running in your cloud workloads. So it is highly distributed and dynamic. And there are different components running across multiple nodes, and it just makes it more difficult to monitor and secure. So by monitoring these applications, containerized applications, the administrators can gain visibility into behavior of these applications and therefore identify security issues. And you can also take actions to mitigate these issues. So when you talk about monitoring, I'm going to talk about infrastructure monitoring, application monitoring, and application monitoring. So with infrastructure monitoring, containers rely on the underlying infrastructure, such as the host OS. They rely on the network and the storage to function properly. And you do have infrastructure monitoring tools that can help detect any issues. They can help detect vulnerabilities in the infrastructure, such as resource utilization, latency, network latency, and also the storage capacity. So these are things that could actually impact your container performance and security. And you also have the traditional application monitoring, and within containers, what you can do with application monitoring is containers are used to deploy and run applications, and APMs or application monitoring tools can help detect any issue or vulnerabilities in the application code. So, to detect things such as memory leaks, errors, or any application crashes that could impact container performance and security, you can use application monitoring. And you have to monitor both. So teams can actually gain a comprehensive understanding of the environment if they have a monitoring solution in place. All right, so that wraps up the the basic use cases and the whole flow of container security, leading all the way to monitoring. I have a demo, and as I said, I will just click on the next slide where it shows the GitHub repo for this presentation. So the entire demo is actually here if you want to try it on your own. But sorry. But let me I'm not going to go through the entire process, but I've started out with creating the environment. So let's look at that. I'll actually stop the slideshow and go to my terminal. Can you see the terminal window?
We see the demos, the slide 6.
Oh, you just see that. Okay. Share.
Yeah, now we see the terminal.
Okay. Okay. Got it. So, so for this demo, I'll keep it really simple with the environment. I've just used my laptop
Sorry,
here.
Gary. Yeah, I don't know if I know people are all on their computer, so maybe it doesn't matter, but maybe if you could make the
Oh, the
font
font bigger.
tiny bit bigger.
Sure.
Yeah. Thank you. Yeah, that's yeah.
It was good. Okay.
Yeah, it's hard to know nowadays, since it's not in a room and people are not sitting in the back, how big it needs to be. Just a little bigger.
So this demo is actually using multipass, which is a quick plugin that you can use to spin up clusters and containers. You could also use, so depending on your Mac or your PC, whatever you're using, and depending on the version, multipass could work or can give you trouble. So in that case, I would encourage you to check what the driver is, or your virtualization driver is. So I'm currently using Kimu. By default, I think Mac uses I forgot what it's called, but anyway, so you could use VirtualBox or Kimu, and for my setup, I'm using Kimu. And to start with, I've already started. I've created the nodes already. There's one control node and two worker nodes.
Are you saying multi-class isn't? It's like an alternative to like Kind or Minikube? Is that?
Yeah. It's an alternative to Kind. Yeah,
Cool.
you could use Kind too. So since some of the setting up these nodes can take a few minutes, I just before the presentation I ran the commands, and you can see 3 nodes currently running, the control and the worker nodes, and it has some IP addresses assigned to it. It's running Ubuntu 22.04. Okay, so what we do after this is there is a transfer command to move all the kubeconfig files from multipass VM to my computer to access the cluster. So let me see if I can do that. Okay. So I'm just doing the transfer of the kubeconfig file to the k3s.yaml, and if I open that file, YAML file, you will see that the server IP is the local host IP, and we don't want this. We want this to be the actual IP of the control node, which is 168.64.12. And my dear friend Reza has included some commands to easily do this. So I'm just exporting the config, getting the IP of the control node and transferring it to the YAML file. Oh. Okay, so now if we go to the YAML, we can see that it's the server IP is 64.12, which is the same as the control node IP. All right, so what we do next is there is a Hello World app for using two container images. So let me move on to the next part. So we've set up the environment. We have all the infrastructure. We have 3 nodes. Next part is we look at container security. I spoke about image scanning and all that, building container images. So I'll use a Docker command to build 2 container images. So one will be a test image called loose, which will have oh, so I have to go to the container security folder here. Okay, so this will build something with few extensions and files. So we'll see how it looks once it builds.
So basically, you
image.
created a cluster with one control plane node and 2 worker nodes, and now you're deploying an application that consists
yes.
of containers.
Yes, it's a very simple Hello World application with and I'll do it with 2 container images with different base image layers. And what we'll do is scan this once we are done. So one is with some image that has a couple of extensions, and one is with minimal, which is the least amount of extensions or
and you're but you haven't installed Calico.
Not yet.
Okay, and so this scan that's happening right now on the screen.
So this is not scan. So this is actually building the application. What you see here, the last line is, I think by default, Docker is saying use Docker scan to run.
A recommendation.
So, yeah, that's a recommendation. We're not scanning yet. So what we've done is just build the application.
Okay, so you had 2 application source codes with a Docker file. So you just Docker build them. Okay.
Yeah. And I've already downloaded the Tigera scanner. I spoke about the scanner, right? So this is a CLI-based scanner that you can download from our docs page, and I hope the slides will give you the GitHub link will actually have links to the documentation page. Just to make things simple, you can go to docs.tigera.io. So that's the docs page, and you'll be able to find the scanner there. Download it, just one single command, and you can download the scanner. And what I'm going to do right now is to scan these images, and we'll see what vulnerabilities it reports. And before that, I'll just do a Docker image. Oh man, I have so many images now. I think this is because Calico was installed on this prior to doing the lab. So let's just do the scanning. So I'll do first scan the loose image first. So the command is just Tigera scanner, scan, and then the image.
Is there a cluster-based version of this CLI scanner?
You mean scan the entire cluster?
No, just a cluster that runs in Kubernetes rather than in the.
Oh yeah, you can. Yeah, you can do that too. Yeah. I don't know if it's available with this current release, but I think that is coming. That should be available.
Gotcha. Is the scanner, because Calico is open source, right? Is the Tigera scanner also somehow free?
No, so this is closed source, but you can download it for free. There's no charge to download the scanner. You can also see the results. I mean, I would consider it almost open source because you can actually find vulnerabilities. So right now I've not installed any license or anything, and I'm still able to use it. So what I've done here is I've scanned this test image .loose, and it has given me, since the output, I've increased the font size to, it's much bigger. So the output looks really messy with so many lines. But if you set up the font to be the correct size, it's just a 2-column or 2-row output. And what it's done is it has found out 2 CVEs here with medium severity. And you could find more information on this particular CVE if you go to the website that's part of the link that's part of the output. So yeah, that's the result for the first image. And let's see for the minimal image where it doesn't use any extension. It has a different base image. What the result it throws out. So here you see there's nothing. There's no CVs, no vulnerabilities. In a real life scenario, this image is good to use. So that's just a simple example. Of course, you can do a lot more with the if you get the commercial version, you could export this scan results, look at a UI page and all that. But for a start, this is a good start to learn what the scanner can do. And next we'll go to the the fun part of Kubernetes. Start using the kubectl, get nodes, and see the status for these nodes. So you see here, it's not ready because your CNI is not ready. So that's why I mentioned that CNI is not a nice to have, it is a must have. And unless you install the CNI, your nodes are not going to come up because they have no idea that the other node exists. So this cluster, it requires a CNI now, and we'll install Calico to fix this. I'll just use the same, all these commands will be in the GitHub, but it's also part of the docs where you can go look on how to install the Calico. I'll use a operator-based command where I just have I'll create just this one line where it fetches the manifest, the type data operator YAML file. And if it goes through well, correctly, this might take a few seconds. Okay, it's done. And I think this might take a couple of minutes to come up. Got to get pods. Okay, we'll wait for the nodes to come up. But before that, I also spoke about the image registries, right? Private and public image registry. So we'll create those. So again, I'm going to use the manifests that are already available with our project Calico. So you can see the images in this registry, right? I don't know how people pronounce this. In Australia, it's pronounced as key, but in the US, I've noticed many people say que, whatever it is. So that's a very widely used registry, que or key.io, and our operator is in this registry here, and it's a public registry. When it comes to a private registry, what I'm going to do is use a command to run a new VM to host the private repository. And again, I'll use multipass to do this, to create a private image registry. So it launches a private repo with 60 gig of memory.
What is the file, that init file that, so you're saying launch? Yeah,
So
launch.
these,
Mhm.
let's look at that init file.
I guess it's, oh, I see, I understand. Okay, so it's probably, so you're launching, so multipass has a way of launching a repo.
Mhm.
And I guess this registry init file must be configuring it to be private rather than public.
Yes, let's actually see
Okay.
here. These are the Docker file. I thought the init YAML should be here. Release.
Is multipass only K3s or is also Kubernetes?
I think it should work with Kubernetes, but in this case, we're using K3.
Hmm.
Application normalization. Oh, okay.
And I don't know, do you want to say, I guess, a few words about Kubernetes versus K3s in that choice?
So yeah, K3 is lightweight Kubernetes. I mean, so like I said, I'm not super technical to give you the correct differences, but as far as I know, it's just a lightweight version of Kubernetes, and I think it's offered through Rancher, if I'm not mistaken. That's why, I mean, you are able to do this on your laptop with a 16. I think my laptop has 16 gig RAM, and if I were to install a proper full blown installation, I don't think it'll support.
Mhm.
So this is the registry init.yaml. Yeah, I think it's just creating the private or public registries. Okay, so that is also done with a private repo. And what we'll do next is okay, so what we're going to do next is a series of push and pull commands with Docker. I'll see if I can do this in a quick way. Let me try copy pasting the entire command here and see if this will accept the so what is happening here is we are pulling the Calico version. So Calico has a lot of components within Calico called Taifa, the CNI, the kube controllers, as you see here. And each component is being pushed to these registries. First, you're pulling it, tagging it with the version, and pushing it back to Docker. So
So pulling it from Docker Hub and pushing it to the local registry on your
yeah,
K3.
yeah. In this case, not Docker Hub. In this case, it's the private registry that we created.
The Docker poll is not from Docker Hub?
No, no, it's from the private registry. So I think I probably shouldn't try this bulk command. I think it's not working. I'm trying to kill this command now.
Is this part of like just the demo of a private registry, or is this part of the installation of Calico?
No, no, this is not. This has nothing to do with the Calico installation. This is just to showcase the public private registries and how it works. The installation of Calico will just take a few minutes and not even you don't have to do any of this. It's just a single operator command. Let me see how I can kill this now. Okay, these are running. Okay, I guess what's happening is I think I shouldn't have given all these commands in one go. So I most likely screwed up the installation, but let's see. We'll move on. I can come back to this. But the basic idea behind doing this is to show how the private and public registries work. But let's try with network segmentation and isolation if we can get to that part of the demo.
Okay. The value in the registry environment variable, that's the private registry?
Yeah, yeah.
And are you authenticated to that private registry already?
Should be. There was I mean, I think it's all self-signed, so I don't think authentication should be a problem. But I really don't know how to troubleshoot this right now. And I think the kubectl is trying to access some EKS clusters that I brought up yesterday.
Yeah, it feels like it should probably be going, right?
And trust me, Reza would have done a better job with doing it patiently.
Very grateful that you're here. No worries. Sometimes demos work, sometimes they don't.
Yeah.
I had to give a presentation today, and like within the last maybe 5 minutes before I had to present, I broke my demo.
Oh no.
Yeah, and so
Yeah.
like part one worked and part two didn't work, and luckily there was somebody else in the room who had an environment
Mhm.
that I could use to show what would have happened if my
Yeah.
demo worked.
Right.
But sometimes you can't solve something in time.
Yeah. Let me try this. Just gonna start from scratch. Processes. Let's see if I can do this again. So if things don't work, we can wrap up with maybe just showing it on the GitHub. You can just explain what's going on there, but let's see. I'm not sharing now, right?
You're not
don't see
sharing right
anything?
now. No.
Okay. Okay.
So right now we're looking at your demo 6 slide. Your slide, yeah. Your slide 6 that says demo.
Oh, okay. Um, I think my multipass is crashed.
Okay.
So
No worries. I
at
still
this
learned a
point,
lot.
yeah. At this point, I think it'll be too much of waste of time to recover that and
Yeah.
go
Okay.
through the demo. But can you see my screen here? Let
Yeah,
me
we see
see if I
Stack
can.
Overflow. Now we see your slide. Yeah.
Okay, so The last slide here has a GitHub repo, and I mean, this guy Razor has done a really good job of documenting everything. So once you have the required minimum hardware, you can go through the entire demo. We did look at container security right up until the end, but we could not get to the segmentation and best practices. So I'll just quickly go through what namespace isolation and RBAC, all these controls do is. So over here, what you will see is just one line of command for setting up namespace monitoring and all that. But behind the scenes, what it does is all these Calico policies that I spoke about. It'll apply labels and namespaces, labels for these namespaces, so that you're basically restricting communication between different pods and different namespaces. So that's what all these commands here will do. And RBAC is also integrating with the Kubernetes RBAC, where you can have different teams or individuals based on their roles. You can control who can set what kind of policies within the cluster. And yeah, service account is very similar with Kubernetes. It's an identity that is used by a pod, so it's almost like a label. And also cluster binding. All these are things that resources that you can use for segmentation. And best practices will be these will most likely deal with Calico policies where you have things like policy precedence, which policy will get executed first, the order of precedence, and also some of the must-have policies in place when you have Calico because you don't want to create a default deny for Calico itself. Then you cannot do anything. You cannot even access the CNI and perform any function. So that's what preventing a lockout here means. So you create some kind of policies by default where you allow certain Calico components to communicate with each other, and then you start building global default deny policies for zero trust, and start building allow policies for each workload. So that's basically what these commands do. And if you look at it, it's actually more of theoretical and architecture with some of the commands. From a demo perspective, I wouldn't be doing justice to the entire demo if I just copy just few commands without you understanding what's happening. So even if you want to try these out, whatever I've spoken until now, just given you a brief description of what these commands do or what these different components do, I think that'll be helpful when you're trying these commands out. And some nodes will communicate to the API, Kubernetes API server. So if you're familiar with the different components within Kubernetes, the HCD, the Kubernetes API server, the DNS server, all these components always keep communicating with your application. So the best practices, everything under this section of best practices will talk about policy design for all of these components.
Cool.
Yeah, so what else did I miss? I don't think we had, oh yeah, I would have loved to do this cool monitoring demo where you create a Prometheus dashboard. And trust me, it all worked fine until yesterday. I crashed I should have been patient with the registry demo, but anyway. So the Prometheus part is where you can actually, using help charts, you can create Prometheus metrics for Calico, and it will give you a nice dashboard with, yeah, so this one won't work right now. This would have given you a nice dashboard with all the metrics for monitoring your traffic. And yeah, what you might
those metrics would have been coming from Calico.
Yeah. and what you would have ended up seeing is a nice dashboard with yeah, before you when you at least get to this point of the demo, make sure that you understand what this means. The localhost 1990, you use the correct ports when you're opening up your browser. And you know, I don't know what he's, oh yeah, he's used the semicolon. So yeah, that's the end of the presentation and the half-baked demo. I apologize that it didn't, I couldn't, do the end-to-end demo, but yeah.
No, don't feel bad. No, that was great. I learned a lot, actually. Thank you for thank you for the presentation. Thank you for humoring
Sure,
all the
yeah.
questions. It certainly helped me put something straight in my head and just clarify some things that I was sort of vaguely familiar with.
Mm-hmm.
So I hope that and yeah, if anybody else has questions or
Yeah,
want to say
yeah.
anything, we're here. We're really grateful that you all are here. Definitely nice to
Yeah,
see you. Brian is one of our colleagues from VMware. He
Oh,
also
okay.
helps
Yeah,
organize sometimes.
for a second, I was thinking he's just smiling at me struggling with the comment, and then I realized it's a picture.
I'm sure Brian's still smiling. He's
No,
always
thanks for, yeah, I try to keep it upbeat,
yeah.
But yeah, it was a very interesting presentation, and I usually work with a different CNI, so it was a good window into, some other technologies that are going on. I have a special place in my heart for eBPF because I worked at a company called Plum Grid some years ago. And they did some pioneering work on that technology. So it's cool to see it, continuing to take over the kernel.
Yeah, yeah.
Yeah, I first learned about eBPF at on the, booth floor of some conference. And so, yeah, as I'm hearing the comments that you're making right now, I guess this knowing that Calico now supports it is right. Sense. I mean, it's an indication of the success of eBPF and the growth.
Yeah.
Yeah, excellent technology and really a great presentation. So thank you very much for joining us. And
yeah. So okay, so I guess that's probably a wrap for us. So as I was saying this earlier, but we haven't quite published the events yet, but we do have 2 more meetups scheduled. We're going to have a May 18, which is going to be a presenter from the company Acuity, and he's going to talk about Argo CD and a new OSS project called Cargo, which I don't know much about, but Alan Lynn says, thank you, great presentation. And then on June 1st, we're going to have someone from AWS talking about multi-cluster, multi-region deployment strategies for resilience and other good stuff. So that's what we have planned, what we'll be announcing soon. And Giri, thank you so much. Thank you. I know you did step in for Reza at the last minute. I'm sorry Reza couldn't join, but we are very happy and honored to have you. It's nice to meet you.
Yeah, thanks for having me. Yeah.
You did a great presentation. Avinash also says thank you. And Avinash will try to organize a Kubernetes 101 at some point. So please also keep an eye on the group.
Yes, sure. Like I am now boosted up with this content because I'm looking at the presentation and I know I would be now I have some comparisons of the CNI platforms like for this material, like comparisons between CNI providers, Calico and other stuff. So I'm now boosted up and now I'll definitely be joining other events and definitely it would be great learning for me. I now think, yeah. Thank you guys.
Thank you. Okay, so yeah, I think Gabri, we can probably stop the recording.
Let's stop. Yes.
Hi everybody. And then